Right now, you are riding on a planet spinning at 1,000 miles per hour while orbiting the Sun at 67,000 miles per hour. That Sun is a nuclear giant, over 1 million times larger than Earth, burning for billions of years in the darkness. It is only one star out of 400 billion in the Milky Way, a galaxy so wide that even light takes 100,000 years to cross it. But here is the truth that bends the mind. Our entire galaxy, with its countless stars and possible worlds, is just a single grain of sand on a cosmic beach filled with 2 trillion galaxies. If you love journeys that transform the way you see reality, support this channel, hit like and subscribe. Prepare yourself, we begin. Look around you. The floor beneath your feet feels still, steady, anchored to the earth. The air hums quietly with life. The world outside moves in familiar rhythms, trees swaying, rivers flowing, clouds drifting across the sky. But this calm is an illusion. Beneath it, you are riding on a vessel moving at unimaginable speed. The Earth spins on its axis, a full rotation every 24 hours. That means if you stand near the equator, your body is already being carried around the center of the planet at more than 1,000 miles per hour. Yet you feel nothing of it. The air moves with you, the oceans move with you, and so the spin hides in silence. But the spin is only the first step of the journey. Earth does not just rotate, it orbits. Each year, our planet makes one full loop around the Sun. To keep this orbit, the Earth races through space at nearly 67,000 miles per hour. Imagine driving a car down an endless highway. At 60 miles per hour, it would take you about an hour to cross 60 miles. At Earth speed, you would cover that same distance in barely 3 seconds. Even that speed is only part of the story. The Sun itself is not fixed. It is rushing through the Milky Way galaxy, dragging the planets with it. Together, we circle the center of the galaxy at around 514,000 miles per hour. Add these motions together, the spin of Earth, its orbit around the Sun, the Sun's journey around the Milky Way, and you are moving through space at over 670,000 miles per hour. Every second of your life, whether waking or dreaming, you are traveling faster than any human-built machine has ever flown. And yet you feel none of it. You sit quietly, watching the world, believing yourself still. But you are not still. You are part of a cosmic dance so vast, so steady that our senses cannot notice it. The Sun we orbit is one among billions. Our star lies in the suburbs of the Milky Way, a spiral galaxy shaped like a great whirlpool of light. We live about 26,000 light-years from its center, close enough to feel the pull of its gravity, but far enough to be spared the violence of its black hole heart. It takes our solar system around 200 million years to complete a single orbit of this galactic core. That means in all of human history, from the first stone tools to modern science, we have barely moved a fraction of a fraction around that immense circle. Think about what that means. Dinosaurs walked the Earth 65 million years ago. They lived and died before the solar system even made it halfway around the galaxy once. The ground beneath us holds bones of creatures that rose, thrived and vanished before we had finished even a small arc of this slow galactic journey. Our species, our languages, our cities, they are flickers of firelight against a backdrop that turns at a pace beyond imagination. Here's a simple fact. Our galaxy, the Milky Way, is about 100,000 light-years across. A light-year is the distance light travels in 1 year, about 6 trillion miles. So the span of our galaxy is roughly 600,000 trillion miles wide. The numbers stretch beyond thought, so let us put it another way. If you could drive a car at highway speed, 60 miles per hour, across the Milky Way, it would take you over 1 billion years to reach the other side. 1 billion years time enough for stars to be born, live their shining lives, and collapse into darkness. Still, even this thought is hard to hold. Our minds were built for rivers, mountains, and the horizon line. We are small animals on a small planet, evolved to survive in forests and fields, but our minds have grown restless. They ask questions the forest cannot answer, and so we reach outward with telescopes and with thought to understand the stage upon which our story is played. The Milky Way is not a single glowing disk of stars. It has a structure, a pattern, written by gravity and time. Its arms curve outward like ripples of light, winding slowly around the centre. These arms are rivers of stars, dust and gas, nurseries where new suns flare into being. Between them are dark lanes where clouds of dust block the starlight. And at the very heart of the galaxy lies a mystery. A supermassive black hole, millions of times heavier than our sun, hidden within a storm of stars. We circle this heart without ever nearing it. Our place out here on the edge of a spiral arm is calm compared to the chaos of the centre, and in that calm life was able to rise. Here is a thought both comforting and unsettling. When you look up at the night sky, you're seeing only a thin strip of this galaxy. All the stars you can name, the constellations, the familiar patterns, belong to our Milky Way, and yet they are not even a fraction of what is there. Astronomers estimate that our galaxy holds between 100 and 400 billion stars. If you tried to count them, one every second, day and night without stopping, it would take you over 12,000 years to finish. Entire civilizations could rise and fall in that time, and still your counting would continue. And even then, your task would not be done, because stars are not the only residents of the Milky Way. There are planets, possibly trillions of them, circling those suns. There are moons, asteroids, comets, clouds of gas, fields of dust and objects we have not yet named. Our galaxy is a city of light and shadow filled with mysteries still hidden from us. And yet, for all its size, the Milky Way is just one city among countless others. Imagine standing on a beach. The grains of sand beneath your feet seem infinite. Astronomers tell us there are more stars in the universe than there are grains of sand on all the beaches of Earth. Our galaxy is but a single grain, glittering faintly, lost among trillions. But before we wander beyond it, let us hold our focus here, on this grain, our home. Because to understand the universe, we must first understand the place from which we look out. Now consider one more detail. Space is not empty. Between stars there is distance, yes, but there is also invisible matter. Dark matter, it is called. It does not shine, does not glow, does not touch our eyes, and yet it shapes the galaxy. Without it, the stars would scatter into the void. With it, they remain bound, whirling together like leaves caught in a hidden current. The truth is this: we live in motion, inside a spiral of fire and darkness, riding a planet that spins and circles and drifts without pause. We are travellers who mistake ourselves for stillness. Every breath we take, every word we speak is carried through the galaxy on a journey we did not choose, but one we now know. In this awareness lies both wonder and humility. Our daily struggles, our triumphs and fears are small ripples compared to the cosmic sea, but they are ours. They are the flicker of consciousness inside a vast, indifferent dark. And perhaps that flicker is what gives the darkness meaning. The question that now rises is this: if the Milky Way, with its hundreds of billions of stars and unimaginable distances, is only a grain of sand, how many more grains are scattered beyond? What waits outside this city of light? And how vast must the universe be, if even our home is dwarfed into near nothingness? We are ready to step beyond. Imagine rising far above the Earth, higher than clouds, higher than satellites, higher than even the glow of our atmosphere. Keep rising until our sun is just another star behind you. until the Milky Way itself comes into view. From that impossible distance, our home galaxy reveals its true shape. It is not a simple ball of stars. It is a spiral, a vast whirlpool of light turning silently in the dark. Its arms stretch out like ribbons of fire, curving in elegant sweeps. To look upon it is to see a frozen storm, a storm that takes hundreds of millions of years for even one full turn. The Milky Way is not solid. It is thin compared to its width. Imagine a dinner plate, wide across but shallow in depth. Our galaxy is the same, about 100,000 light-years across, but only a few thousand light-years thick. Yet within that flat disk lies everything we know, our Sun, our Earth, and billions upon billions of stars. From our position inside it, the spiral arms are difficult to see. It is like living deep in a forest. You cannot see the shape of the forest itself, only the trees around you. But with telescopes and careful mapping, astronomers have pieced together the great pattern. Our solar system lies on the edge of one such arm, a minor one called the Orion Arm. It is like a side street compared to the galaxy's great avenues. From here, we see the other arms stretching faintly across the night sky, great lanes of stars and dust that shine as the Milky Way band we know. At the very centre of the spiral lies something hidden, something powerful. It is a region called Sagittarius, a star. There, crowded stars whirl around an invisible anchor, a supermassive black hole, about 4 million times the mass of our Sun. We cannot see the black hole itself. It swallows all light, but we see its influence. Stars whip around it at incredible speeds. Gas clouds fall inward, heating up until they blaze with X-rays. It is the beating heart of our galaxy, a heart of darkness that holds the spiral together. And yet this darkness is also what makes life possible. Without the weight of the black hole, without the invisible hand of gravity pulling the stars inward, the Milky Way would drift apart. Instead, it spins in balance, each star tracing its path in a dance that has lasted for billions of years. Now imagine travelling outward along one spiral arm. These arms are not solid highways of stars, but patterns, waves of density that move through the galaxy. Within them, clouds of gas collapse, and new stars are born. They flare bright, live fast, and die young, scattering their ashes into space. This cycle has gone on for untold ages, filling the arms with both brilliance and dust. Our own Sun was once born in such a cloud billions of years ago, and one day, long in the future, it will return its material back to the galaxy to be used again. Between the arms are dark regions, lanes of dust so thick that they block starlight. When we look up on Earth and see the Milky Way crossing the sky, we often notice these dark rifts, like rivers of shadow splitting the light. They are not empty, they are nurseries, filled with the raw material for future stars and planets. To the eye they appear as absence, but in truth they are the womb of creation. There is another strange feature of the spiral. It is not flat. It is warped, bent slightly like a wave. The edges curl upward and downward, twisted by the pull of nearby galaxies and the unseen influence of dark matter. From afar it would look like a plate bent by invisible hands, a ripple frozen into its shape. When we map the galaxy in other forms of light, in radio waves, in infrared, we see even more detail. We see enormous bubbles of energy bursting from the centre, relics of ancient eruptions. We see streams of stars flowing in arcs, leftovers of smaller galaxies swallowed by the Milky Way long ago. Because the Milky Way is not only a home, it is also a predator. Over its life it has consumed countless smaller galaxies, tearing them apart, weaving their stars into its arms. Our spiral is a history of violence written in light, and yet we are safe here on our small street, the Orion Arm, far from the violence of the centre, far from the edges where galaxies collide. In this calm place, life had time to appear, to evolve, to wonder. If Earth had been born closer to the black hole, the radiation storms would have ended us before we began. If it had been too far out, there may not have been enough heavy elements for planets and bodies like ours. By chance or by necessity, we are in a habitable suburb, balanced between chaos and emptiness. Let us pause to compare. The Milky Way is one galaxy among trillions. Yet within its spiral arms lies a richness beyond imagination. Consider this. If each star had just one planet, there could be hundreds of billions of worlds here. Some may be barren, frozen deserts. Others may be boiling seas. And some perhaps may be alive. The galaxy's arms could hold entire civilizations, hidden from us by distance and time. But the vastness between stars is so great it may keep us apart forever. Think of the nearest bright star, Sirius. It lies about 8.6 light years away. That means the light we see tonight left Sirius almost 9 years ago. If we tried to travel there with our fastest spacecraft, it would take tens of thousands of years to arrive. And Sirius is one of our closest neighbours. Across the spiral, stars are scattered like islands in an endless ocean, too far for easy crossing. This distance is why the Milky Way feels at once crowded with stars and impossibly empty. Some mysteries remain unsolved. For example, why does the galaxy spin so fast without flying apart? The stars at its edge move faster than they should, as though pulled by something unseen. Astronomers believe this something is dark matter, a hidden mass that outweighs all the visible stars. But we do not yet know what dark matter is. We cannot touch it, cannot see it, can only measure its pull. It is the skeleton of the galaxy, the invisible frame that holds the spiral together. Others wonder about the black hole at the centre. Did it grow from a single collapsed star? Or was it born massive in the universe's youth? Could it one day erupt again, flooding the arms with deadly radiation? We do not yet know. The heart of the spiral keeps its secrets close. And then there is the question of shape. Why spirals? Across the universe, spiral galaxies are common. Their arms curve in similar patterns, as if the cosmos prefers this form. The answer lies in physics. Spirals are natural when matter rotates and collapses under gravity. But still, there is a beauty to them that feels almost intentional, as if the universe delights in order within chaos. So here we are, inside a spiral galaxy, thin as a plate, vast as a dream, filled with stars beyond counting. We cannot step outside to see it whole, but we can imagine. We can map. We can simulate. And in those visions we glimpse the truth of our home, a whirlpool of light turning silently in the dark with our tiny planet circling one star among billions. And yet the spiral is only the beginning. Beyond it lie other spirals, other shapes, other galaxies drifting through the void. Some will come near. One, the Andromeda galaxy, is already falling toward us on a collision course that will one day rewrite the shape of the spiral forever. But that is a story waiting just ahead. Lift your eyes to the night skim. You see only a handful of stars, maybe a few hundred on a clear night, far from city lights. They sparkle like diamonds scattered across velvet. Yet what you see is only the tiniest fraction of what exists. The Milky Way holds hundreds of billions of stars, far more than our eyes can ever drink in. Counting them all would take longer than entire human civilizations have existed. Imagine this: if you started counting one star every second, tick, 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 without ever stopping, it would take you more than 12,000 years to finish counting just the stars in our galaxy. That is longer than the whole span of written human history. Empires would rise and fall, languages would be born and lost, and still you would be counting. But let us try to picture the number in another way. Take a beach, scoop up a handful of sand. Each grain seems too small to matter. Yet scientists estimate that there are about 7 quintillion grains of sand on Earth's beaches. That is a number so large we cannot truly imagine it. And still there are more stars in the universe than there are grains of sand on all the beaches of Earth. Every tiny grain beneath your toes is like a star, burning or dying with worlds circling it. Suddenly the night sky feels much larger than what your eyes show. Our Milky Way galaxy alone may contain between 100 and 400 billion stars. Why is the number so uncertain? Because we cannot see them all. Dust clouds block much of the light. Some stars are too dim, too small, or hidden in crowded clusters. Astronomers use careful measurements, looking at light, mapping orbits, weighing the galaxy, to estimate. But even the best estimates leave room for mystery. Somewhere in those dark lanes are countless stars we have not yet catalogued. Most stars are not like our Sun, may have far larger, burning hot and bright, but living short lives. They shine for only millions of years before collapsing in violent supernovae. Others are far smaller, red dwarfs, cooler and dimmer, but living for trillions of years, longer than the universe has even existed so far. Our Sun is somewhere in between, average in size, average in brightness, an ordinary star in an ordinary neighbourhood. Yet from such ordinariness life emerged. But stars are not alone. Almost every star has companions, planets, moons, rings, or belts of icy fragments. Astronomers now believe there may be more planets in our galaxy than stars. Trillions of possible worlds, each with its own story, its own weather, its own possibilities. Some may be gas giants with storms larger than Earth. Others may be rocky and barren, baked or frozen. And some perhaps may hold oceans, continents, and maybe even life. When we look at the Milky Way in the night sky, we see it as a glowing band stretching overhead. That band is not made of mist or cloud. It is made of countless stars too far away and too crowded together for our eyes to separate them. Every faint blur is thousands of suns. Every pale smear is a distant cluster. What appears as a single point of light may in truth be hundreds of stars shining together. Astronomers often use analogies to bring these numbers closer to us. One of the most striking is this. If you turn the stars of the Milky Way into a city, Earth would be a single house on a single street. The Sun would be a modest lamppost. The nearest star would be another lamp 4 blocks away. And the rest of the city would stretch beyond the horizon, filled with lights we cannot hope to reach. Consider Sirius, the brightest star in our night sky. It lies only 8.6 light years away, a close neighbour in galactic terms, but in miles that distance is staggering, over 50 trillion miles. Even if you drove at highway speed 60 miles per hour, it would take nearly 1 billion years to arrive. And Sirius is one of the closest stars. Most are far more distant. Space is not crowded, it is empty. So empty that even the billions of stars in our galaxy seem like isolated islands in a dark ocean. Here lies a paradox. The galaxy is overflowing with stars, yet it is also incredibly empty. The distances between them are vast beyond imagination. This is why the sky feels both full and lonely at once. It glitters with light, yet between those sparks lies unending darkness. There are also strange kinds of stars. Some are giants so big they could swallow our entire solar system. Others are tiny, collapsed remnants, white dwarfs or neutron stars that pack the mass of the Sun into a ball the size of a city. And in rare cases there are black holes, where gravity is so strong that not even light can escape. Each of these stellar lives is a different path, a different destiny written in nuclear fire. And what about the unknown? There is debate among scientists about just how many stars the Milky Way holds. Some suggest it may be closer to 1 trillion, others say the number is smaller. We also do not yet know how many of those stars truly hold planets and how many of those planets might be Earth-like. Our telescopes have found thousands of exoplanets, but most are too far away to study closely. Somewhere in that great uncounted sea, there may be worlds that look very much like ours. Speculative thinkers go further. They ask, if the galaxy has hundreds of billions of stars, and if many of those stars have planets, and if life can appear here, why not elsewhere? Should the galaxy not be teeming with civilizations? And yet, when we listen, the stars are silent. This puzzle is known as the Fermi paradox. It whispers a question into the night. Where is everyone? Are we early, the first to awaken, or are civilizations like ours doomed to vanish quickly, leaving little trace? The answer remains hidden among the stars we cannot yet reach. To hold these thoughts is to feel both small and vast. Small because we are one planet around one star in a galaxy overflowing with suns. Vast because we are part of that galaxy, connected to each light, bound into the same spiral. Our bodies carry atoms forged in long-dead stars. The iron in your blood, the calcium in your bones, the oxygen you breathe, these were born in stellar furnaces billions of years ago. You are made of starlight. So, when you look up at the Milky Way, you are not only counting stars, you are also counting ancestors, distant relatives, the furnaces that gave birth to you. Every point of light is both a mystery and a memory. And still, beyond this glittering sea, waits another. Our nearest great neighbor, the Andromeda Galaxy, looms in the distance. It holds more than 1 trillion stars, and one day it will meet our Milky Way face to face. When it does, the stars we have tried to count will be scattered, reshaped, woven into a new galaxy. The act of counting, then, is not only impossible, it is temporary. For even galaxies change, merging and growing, while the stars within them are born, live and die. So perhaps the act of counting is not what matters. What matters is wonder. To look at the night sky, to let the numbers wash over you, to realize that in the span of one human life you cannot count the stars, but you can feel them. You can let their light enter your eyes. You can carry their story in your breath. And in that way you are already connected to them all. Far across the night sky, in the direction of the constellation Andromeda, lies a ghostly blur. To the naked eye it looks like a faint smudge, as though a fingertip has brushed across the darkness. Yet this smudge is no cloud, no trick of light. It is another galaxy, the Andromeda Galaxy. Unlike the stars, which sparkle with a sharp brilliance, Andromeda glows softly, like a candle seen through fog. It rests about 2.5 million light-years away. That means the light reaching your eyes tonight began its journey before the first humans walked the Earth. When it left, our ancestors were still small, ape-like creatures learning to stand on 2 feet. All of human history, every word, every empire, every dream, has played out in the time it took this light to cross the gulf of space. Andromeda is not just another star system, it is vast, even larger than our own Milky Way. Where our galaxy holds a few 100 billion stars, Andromeda may hold over 1 trillion. Imagine a city of light so immense that even the Milky Way, with all its brilliance, seems modest beside it. Now imagine this. Andromeda is moving. Slowly, steadily, it is drifting toward us. While most galaxies in the universe race away, carried by the expansion of space, Andromeda and the Milky Way are bound together by gravity. They are on a collision course, falling toward each other across the void at around 250,000 miles per hour. That speed is almost impossible to grasp. At such a pace, you could circle the Earth in less than 10 minutes. Yet in cosmic terms, the galaxies still move slowly because the distance between them is so enormous. Scientists estimate that in about 4.5 billion years the two galaxies will meet. They will not crash like solid objects because galaxies are mostly empty space. Instead, they will pass through each other, their stars flowing like waves of light. Some stars will be thrown out into intergalactic space, flung far from any home. Others will find themselves caught in new orbits. Over time, the two spirals will merge, forming one giant elliptical galaxy. Astronomers have already given it a name, Milkomeda, a marriage of Milky Way and Andromeda. It sounds violent, but on the scale of stars, it is more like a dance. The chance of two individual stars colliding is almost zero. Imagine two swarms of bees flying through each other, each bee weaving past countless others without touching. The stars will do the same. They will weave past their gravity-tugging, reshaping orbits, creating new patterns. For our sun and its planets, the odds of a direct collision are slim. Earth will almost certainly survive the encounter, but the night sky will be forever changed. Picture that far future. If humanity, or whatever comes after us, is still here, they will look up and see a sky ablaze. Andromeda will grow larger and larger, first a blur, then a majestic arc filling the heavens. When the galaxies finally merge, the sky will be alive with rivers of stars. Where we now see a few hundred pinpoints, they will see millions stretching overhead, a tapestry of light. But this collision raises questions. What happens to black holes when galaxies merge? At the heart of Andromeda lies another supermassive black hole, much like Sagittarius A at our center. When the galaxies collide, these two giants will spiral toward each other, drawing closer and closer until they merge in a titanic event. The energy released in gravitational waves will ripple across the universe, shaking the very fabric of space-time. Somewhere, distant civilizations may one day detect those ripples, proof of a cosmic marriage that took place billions of light years away. There is also speculation. Some wonder if the merger will spark waves of star formation. When clouds of gas crash together, they can ignite, giving birth to new stars. Entire generations of suns may be born in the fire of collision, perhaps even new planets, new homes, new chances for life. And yet, there is a shadow side. For civilizations that might exist in either galaxy, the merger could bring chaos. Star systems may be flung into cold exile, torn from the warmth of their galactic neighborhoods. Others may be cast into radiation storms near active black holes. If life exists elsewhere in these galaxies, the merger will shape its destiny as surely as it shapes the stars. Here lies a mystery. Why do galaxies collide at all when the universe is expanding? The answer is that gravity still rules on local scales. While the cosmos as a whole grows larger, nearby galaxies can still fall together. Andromeda and the Milky Way are bound in the same cosmic family, members of the local group of about 50 galaxies. Their mutual pull is stronger than the expansion of the universe between them. That is why, while most galaxies drift away, these two are destined to unite. But what will it mean for us? 4.5 billion years is a long time. By then, our sun will be nearing the end of its life, swelling into a red giant, burning the Earth. Humanity may be gone or transformed beyond recognition. Perhaps we will have left Earth, scattered across other planets or even other stars. Perhaps we will be dust, remembered only in traces written on stone. Or perhaps some future form of us will witness the dance of galaxies, watching two giants become one. Andromeda, faint blur though it is a reminder of scale. It teaches us that the Milky Way is not the whole. Our galaxy, with its billions of stars, is just one member of a larger family. Beyond it are other spirals, other giants, and other worlds we may never reach. The night sky is not only a window into distance, it is a window into time, into futures we will not live to see but can still imagine. So the next time you see that faint smudge in the dark, remember what it means. It is 1 trillion suns rushing toward us across millions of light years. It is a promise of change, of collision, of creation. It is the future written in light. And beyond Andromeda, there are clusters, superclusters, vast webs of galaxies woven together. Our story does not end with two spirals colliding. It expands outward, ever outward, into a cosmos beyond counting. Step back now, step farther than our sun, farther than the spiral arms of the Milky Way, farther even than the faint glow of Andromeda. When you widen your view, you begin to see that neither galaxy stands alone. They belong to a larger neighborhood, a small collection of galaxies bound together by gravity. Astronomers call this neighborhood the local group. The local group is like a cosmic town. It stretches about 10 million light-years across. Within it are more than 50 galaxies, some large and grand, others tiny and faint, like sparks that barely glow. Together they drift through the darkness, connected by invisible threads of gravity, like beads on a necklace too vast for us to see all at once. At the center of this family stand two giants, the Milky Way and Andromeda. They are like twin monarchs, each with their own retinue of smaller galaxies circling around them. Our Milky Way has more than 50 dwarf galaxies as companions. Some are little more than hazy clumps of stars, so faint they are difficult to detect. Others, like the Large and Small Magellanic Clouds, are visible even with the naked eye from the southern hemisphere, shining like pale smudges in the night sky. These dwarfs are important. They tell us how galaxies form and grow. Larger galaxies like ours are built in part by swallowing smaller ones. We see evidence of this in streams of stars that arc across the Milky Way, remnants of galaxies long ago torn apart and absorbed. Our spiral is not only a home, it is a history book, and each dwarf galaxy is a chapter waiting to be read. Andromeda, too, has its followers. Some are so faint we can only detect them with powerful telescopes. Others drift in close orbit, like moons around a planet. Together with the Milky Way, they dominate the local group. Between them, they hold most of the stars, most of the mass, most of the power. But not all Gala. Xis in this family are spirals. Some are irregular, shaped like clouds torn by wind. Some are ellipticals, glowing spheres of ancient stars. The diversity is striking. Imagine a town filled not only with mansions and cottages, but also with ruins, tents, and strange shifting structures. The local group is just as varied. And then there is the third largest member, the Triangulum Galaxy, smaller than the Milky Way and Andromeda, but still impressive. It is a spiral galaxy with perhaps 40 billion stars, a modest number compared to its neighbours, but still vast compared to human scales. Triangulum orbits near Andromeda, and some astronomers think it may one day be swallowed by it. If so, it will become part of the great merger that awaits in the far future. The local group is held together by gravity, but it is not crowded. Space between galaxies is immense. Imagine a city where each building is separated by hundreds of miles of empty desert. That is how galaxies live in this cluster, close enough to pull on each other, far enough to feel alone. The night sky gives the illusion of closeness, but in truth, the distances are almost endless. And yet, despite these distances, the local group is a family. Its galaxies orbit, tug, and sometimes collide. In fact, our Milky Way has already swallowed several dwarfs and will likely consume more. These events are slow, unfolding over billions of years, but they shape the destiny of galaxies. Without them, the Milky Way and Andromeda would not be what they are today. Speculation enters here. Some scientists wonder, do all galaxies exist in groups, or are there loners drifting completely alone? The answer seems to be yes. Most galaxies are in groups or clusters, but some float in isolation, far from neighbours. These lonely wanderers are mysteries. Were they pushed out, exiled by gravitational tides, or were they born in solitude? Forever apart, the universe keeps that secret for now. Another question. How many galaxies truly belong to the local group? We know of about 50, but faint galaxies are constantly being discovered. Some are so dim that they contain only a few thousand stars. Compared to the hundreds of billions in the Milky Way, these dwarfs seem fragile, like sparks at the edge of a fire, and yet they survive, drifting in the shadow of giants. Dark matter plays a role here too. The visible galaxies are only part of the family. Around them is a vast halo of unseen matter, outweighing the stars many times over. This invisible glue keeps the local group bound. Without dark matter, the galaxies would scatter, pulled apart by the larger currents of the universe. But with it, they remain together, a family tied not by light, but by shadow. When we map the local group, we see that it is not the end of the story. Beyond it lies the Virgo cluster, a far larger gathering of galaxies. The local group is like a small town on the edge of a great city. One day, it may fall into that city's embrace. The local group is not only a family, it is also part of a much larger network, a cosmic web stretching across space. But here, within this local family, we find something meaningful. For in the Milky Way, Andromeda, Triangulum, and their companions, we see echoes of our own story. We see growth through union, survival through connection, and diversity of form and fate. The local group reminds us that even in the vastness of the universe, things exist not only alone, but together. Imagine, then, a night sky in some far-off world, orbiting a star in a dwarf galaxy near Andromeda. To the beings there, if beings exist, the Milky Way might be just a faint smudge, a pale blur on the edge of vision. They might wonder about us as we wonder about them, never knowing if anyone else stares into the night asking the same questions. This is the paradox of the lock. Our group. It is our family, our neighborhood, our cosmic home, and yet it feels silent. Galaxies surround us, but the void between keeps them distant. We share this neighborhood with trillions of stars and perhaps uncountable planets. And yet, so far, the only voices we know are our own. Still, the knowledge of this family changes how we see ourselves. We are not only citizens of Earth, not only residents of the Milky Way. We belong to the local group, a family of galaxies drifting together in the vast sea of space, and that family is itself part of something greater still. Because beyond the local group, other families gather. They form clusters, superclusters, and walls of galaxies stretching across billions of light years. Our neighborhood is only one among countless others. But before we journey into those greater cities of the cosmos, let us pause. Let us remember that even here, close to home, the scale is already more than our minds can fully hold. And yet we try. We imagine, we count, we dream. For in dreaming we take the first step into understanding. Step back farther still. Beyond the local group, beyond the quiet family of 50 galaxies drifting together, there rises something larger, grander, and more crowded. This is the Virgo cluster, a true cosmic city where thousands of galaxies gather in one place. The Virgo cluster lies about 54 million light-years away. That number is difficult to hold in the mind. A light-year itself is about 6 trillion miles. Multiply that distance by 54 million, and you begin to see how far this city of galaxies lies from us. And yet, with telescopes, we can glimpse it across the darkness. Its brightest galaxies shine as faint smudges in the sky, clues to a faraway kingdom of stars. In the Virgo cluster, galaxies do not live quietly. They swarm together in a dense crowd, tugging and pulling on each other with their immense gravity. Imagine standing in the middle of a great marketplace, surrounded on all sides by people brushing past, voices rising, goods being exchanged. The Virgo cluster is like that, only the players are galaxies, each one containing billions of stars. Some of these galaxies are spirals like the Milky Way, their arms curling gracefully through space. Others are ellipticals, huge glowing spheres of old stars, smooth and featureless compared to the complex spirals. These ellipticals dominate the cluster. They are the heavyweights, the skyscrapers in the cosmic city. Some of them are truly colossal, much larger than the Milky Way, with stars numbering in the trillions. At the cluster's center sits one of the most massive of all, Messier 87, or M87 for short. This galaxy is a giant elliptical about 120,000 light-years across, and it holds a supermassive black hole at its core weighing 6.5 billion times the mass of the Sun. In 2019, astronomers captured the first ever image of a black hole's shadow, and it was this very black hole in M87. That shadow was the doorway into the unknown, a glowing ring of fire marking the edge of a gravity well so deep that not even light can escape. The Virgo cluster is not just a collection of galaxies, it is a living environment full of interactions. Galaxies collide here. They merge, tear each other apart, or strip away their stars. The cluster is filled with hot gas, heated to tens of millions of degrees. This gas glows in X-rays, invisible to human eyes but clear to telescopes. It fills the space between galaxies like a cosmic fog. And within that fog are mysteries. Stars have been torn from their galaxies and now drift freely through the cluster, unbound to any home. Imagine entire suns wandering the dark, carrying their planets with them, exiles from the galaxies that birthed them. Some scientists estimate that in clusters like Virgo, there may be more stars floating between galaxies than inside them. If planets circle those stars, entire systems may wander alone, cut off forever from the warmth of a galactic core. The Virgo cluster also reveals the hidden power of dark matter. When astronomers measure the speeds of galaxies inside the cluster, they move too fast for visible matter alone to hold them. By rights, the cluster should fly apart, yet it does not. Something invisible, something heavy, glues it together. This is dark matter, the unseen skeleton of the universe. In the Virgo cluster, its presence is undeniable. Without dark matter, this vast city of galaxies could not exist. Now imagine the scale. The Virgo cluster contains thousands of galaxies. Each galaxy holds billions or trillions of stars. Each star may have planets. The number of possible worlds in this one cluster alone defies comprehension. And the Virgo cluster is only one among many. Beyond it lie other clusters, each one crowded with galaxies of every kind. Here we meet a fascinating fact. Our local group, the small family of galaxies we call home, is on the edge of the Virgo cluster. In fact, we are being pulled toward it. Over billions of years, gravity will draw us into the cluster, binding us into that crowded cosmic city. One day, the Milky Way, Andromeda, Triangulum, and all our companions will be residents of Virgo, just one group among thousands. Speculation stirs here. What happens when clusters merge? If galaxies collide in Virgo, what happens when entire clusters collide with each other? Astronomers believe this does happen, giant clusters crashing together in slow, unstoppable impacts. In one famous case, called the Bullet Cluster, two clusters collided and tore through each other. The visible matter, gas and stars slowed down, clumped and glowed, but the dark matter passed through without pause, invisible yet measurable through its gravity. Events like this show us not only the violence of clusters, but also the strange behavior of the hidden universe. There are still mysteries within Virgo. Why do some galaxies thrive in such crowded places, while others seem stripped and dead? Why do giant ellipticals dominate the centers while spirals linger on the edges? Scientists debate whether the environment of clusters shapes the fate of galaxies, or whether the galaxies that fall into clusters are already destined for certain lives. The answers are not clear. The cluster is a laboratory of creation and destruction, and we are only beginning to learn its laws. For us, Thesis, Virgo cluster is both a destination and a reminder. A destination because in billions of years our galaxy will drift into its embrace. A reminder because it shows us how small we are. Our local group feels large when we stand on Earth and think of billions of stars, but compared to Virgo, the local group is tiny, a suburb compared to a metropolis. And still, Virgo itself is not the end. It is part of something larger still. The Virgo supercluster, a structure hundreds of millions of light years across. Virgo is only one district in that larger city, and even that is just a single thread in the vast cosmic web. But before we leap to those greater scales, let us stay for a moment here, in Virgo's realm. Imagine looking out from a planet inside one of its galaxies. The night sky would blaze with more galaxies than stars. Where we see only a few smudges, they would see thousands glowing brightly across the heavens. Their skies would remind them daily of the crowded universe they inhabit, and perhaps they would ask the same question we do. Why does the universe create such richness, only to separate it with emptiness? Virgo teaches us this. Galaxies are not solitary wanderers. They gather, they collide, they merge. They build clusters and superclusters, weaving together in patterns too large for human eyes but visible to the instruments of science. We belong to this pattern, even if we live far from the cluster's heart. Our journey now moves onward to the hidden forces that shape not only Virgo but the entire cosmos, the invisible matter and energy that decide the fate of galaxies, clusters, and perhaps the universe itself. When we look at the sky, we believe we see the universe. Stars shine like tiny fires, galaxies glow faintly, nebulae bloom in soft clouds of color. But this is a trick of light. What we see is not the whole. In truth, most of the universe is hidden. The stars, planets, and gas we can see make up only a small fraction, barely 5% of everything that exists. The rest is invisible, silent, and mysterious. Scientists call one part of this invisible reality dark matter. It does not shine, it does not glow, it does not reflect or block light. No telescope can take its picture, and yet dark matter is everywhere. It is the hidden scaffolding that holds galaxies and clusters together. Without it, the Milky Way would fly apart, its stars scattering into the void. The story of dark matter began with a puzzle. In the 1930s, an astronomer named Fritz Zwicky studied the Coma cluster, a collection of galaxies. He noticed that the galaxies moved too fast. According to the visible matter, the cluster should have torn apart long ago. Something unseen had to be providing extra gravity, holding it together. Zwicky called it dunkel materia, dark matter. At first, many did not believe him, but in the decades since, evidence has only grown stronger. Look at the Milky Way. When astronomers measure how fast stars orbit the center, they expect the stars at the edge to move more slowly, just as planets farther from the sun orbit more slowly. But they do not. Stars at the galaxy's edge move as quickly as those near the center. The only explanation is that an enormous amount of hidden mass surrounds the galaxy, forming a dark halo. This halo extends far beyond the visible spiral, like an invisible sphere wrapping the galaxy. It is so massive that it outweighs all the stars, gas, and dust we can see. The same is true for Andromeda, for Virgo, for clusters across the cosmos. Everywhere we look, galaxies and clusters behave as if they are bound by something unseen. But what is dark matter? That remains one of science's greatest mysteries. Some think it could be made of undiscovered particles, WIMPs, weakly interacting massive particles, or axions that pass through ordinary matter without touching it. Others wonder if our understanding of gravity itself is incomplete, and what we call dark matter is simply a sign that our laws need rewriting. Despite decades of searching, no experiment has yet caught dark matter directly. Deep underground laboratories wait for particles to strike detectors. Space telescopes scan the sky for signs. Colliders like the Large Hadron Collider try to create it in high-energy collisions. So far, dark matter remains hidden, like a shadow that refuses to step into the light. And yet, though we cannot see it, we can map it. When light from distant galaxies passes through a cluster, the gravity of dark matter bends it, a phenomenon called gravitational lensing. By studying how light bends, scientists trace the outline of dark matter, like mapping the shape of wind by watching how it moves smoke. The Bullet cluster is one of the most famous examples. Two clusters of galaxies collided, their gas and stars interacting, but the dark matter passed straight through. Astronomers could see its ghostly imprint in the way background light was distorted. It was clear evidence that dark matter is real, separate from ordinary matter and dominant in the universe. Now think of the scale. If normal matter, the kind that makes up stars, planets, trees, oceans, even your body, is only 5% of the universe, then dark matter makes up about 27%. That means nearly 1/3 of all existence is this invisible substance. Everything we see, all the galaxies, are built upon a foundation of shadow. Speculation takes us deeper. Some wonder if dark matter forms its own structures, dark stars, dark galaxies, dark planets, hidden completely from our senses. If so, there could be an entire unseen cosmos overlapping our own, a parallel skeleton of matter we cannot touch, perhaps even dark life, built from interactions we do not understand. For now, this is imagination, but imagination often walks close to discovery. The debate continues. What if dark matter is not real? What if instead our laws of physics are incomplete? Modified theories of gravity try to explain galactic motions without dark matter. They can match some observations but fail in others. The argument is not settled, and science remains open. For now, dark matter is the best explanation, but not the final word. Think of it this way. The stars we see are like the tips of mountains peaking above an ocean. Dark matter is the hidden bulk beneath the waves, unseen but essential. Without it, the mountains would crumble and drift apart. Without it, galaxies could not hold their shape. Without it, the cosmic web would not exist. This hidden dominion changes how we see ourselves. We are creatures of light, built from atoms that shine in stars. Yet most of the cosmos is built from something else, something that does not shine. We are the exception, not the rule. We live in a universe where the majority is unseen, and dark matter is not alone. Beyond it lies an even stranger mystery: dark energy. If dark matter pulls galaxies together, dark energy pushes them apart. It makes up nearly 68% of the universe, driving its expansion faster and faster. Together, dark matter and dark energy account for about 95% of all that exists. We live inside a cosmos where what we know is only a sliver, a narrow slice of reality. The thought can be humbling. Imagine walking through a vast mansion at night, carrying only a candle. The flame shows you a few steps ahead, a few walls, a few objects, but most of the mansion lies in shadow, filled with rooms and halls you cannot see. That is our place in the universe. Our science is the candle, revealing fragments. Dark matter is the endless darkness of the unseen halls, waiting to be discovered. And yet, we do not despair. Instead, we are curious. Humanity has always been curious. We chase shadows. We listen to silence. We search for answers, even when the answers seem impossible. Dark matter is a frontier, a boundary where our knowledge ends and mystery begins. So when you look at the night sky, remember, you are not seeing the whole. The light of stars is only a thin veil over a much larger truth. Behind the glitter, an invisible dominion shapes the cosmos. It is silent, patient, and everywhere. And as we continue our journey outward, we will see how this hidden matter, along with the galaxies it binds, is woven into something even greater. A vast web stretching across billions of light years, a structure so immense that it reshapes our very idea of the universe. Step even farther out now, beyond the Milky Way, beyond Andromeda, beyond the local group, and even the crowded Virgo cluster. The view begins to change. At first it seems chaotic, galaxies scattered at random across the black. But when the picture grows wide enough, a pattern appears, a structure so vast and delicate that it feels almost alive. This is the cosmic web. Imagine strands of silk stretched across unimaginable distances, glowing faintly against a dark background. On these strands lie galaxies, like dewdrops clinging to threads. Between them are vast emptinesses, voids so large they could swallow thousands of galaxies. The web stretches across the universe, connecting clusters and superclusters into one grand design. It is not chaos, it is order, written on the largest canvas of all. The cosmic web spans billions of light years. Its filaments are made of galaxies, dark matter, and gas. These filaments cross and weave, forming nodes where matter gathers into enormous clusters. Between them lie the voids, regions nearly empty, deserts of space where only a few lonely galaxies drift. It is a universe of contrasts, crowded strands and silent gaps, light and shadow, matter and emptiness. How do we know this? We cannot simply step back and see it. Instead, scientists map the sky with surveys, measuring the positions of millions of galaxies. When the maps are drawn, the web emerges like veins beneath skin. One of the most famous examples is the Sloan Digital Sky Survey. It revealed that galaxies are not scattered randomly but arranged in filaments and walls, connected across hundreds of millions of light years. Simulations of the universe's birth also show the web. After the Big Bang, matter spread almost evenly, but not perfectly. Tiny differences in density, like wrinkles in fabric, grew over billions of years. Gravity pulled matter into filaments, while dark decay energy pushed space outward. The result was the cosmic web, an architecture born from the tug of gravity and the push of expansion. Think of foam on the surface of the ocean. Where bubbles meet, ridges form. Between them are empty pockets. The universe is like that foam, but on a scale beyond imagining. Each ridge is a filament of galaxies. Each bubble is a void. We live on one strand of that foam, our Milky Way just a single drop on the thread. The web is not only beautiful, it is necessary. Without it, galaxies would not form as they do. The filaments act like rivers, channeling matter into clusters. Gas flows along them, feeding galaxies, giving them fuel to make new stars. Even today, the cosmic web continues to shape the life of galaxies. We are not separate from it, we are part of it, connected by the same threads. At the intersections of filaments lie some of the largest structures known. These are superclusters, regions holding thousands of galaxies. Our own local group lies on the edge of one such supercluster, the Virgo supercluster. But even that is not the end. The Virgo supercluster itself is part of a still larger structure called Laniakea, meaning immense heaven in Hawaiian. It stretches over 500 million light-years, containing more than 100,000 galaxies. And Laniakea is only one section of the cosmic web. The scale is staggering. Imagine trying to walk across a filament of the cosmic web. At human speed, it would take you longer than the age of the universe to cross. Even light, the fastest thing we know, would take hundreds of millions of years. And yet, in the grand design, these filaments are just threads, weaving the universe together. Speculation arises. Could there be patterns hidden in the web that we have not yet seen? Some scientists wonder if the filaments themselves rotate, twisting slowly over billions of years. Others imagine that intelligence, if it exists elsewhere, might use the web as a map, a way to navigate the universe. For now, these ideas are only dreams, but dreams often lead to discovery. The cosmic web also raises questions we cannot yet answer. Why do voids exist? Are they truly empty, or do they hold forms of matter we cannot detect? Do the filaments continue forever, or do they end beyond the observable universe? And is this structure unique to our cosmos, or would any universe born from expansion and gravity form a web of its own? The oddest fact is this: we are trapped inside the observable universe. We can only see as far as light has had time to travel since the Big Bang. Beyond that horizon, the web may continue endlessly, but we will never know. It is as though we stand in a dark room with a candle seeing only a circle of light. The walls may be close, or they may stretch away forever, we cannot tell. Still, what we can see is enough to humble us. The web shows that galaxies are not isolated jewels but beads on strings, parts of a greater whole. Our Milky Way is one bead, Andromeda is another. Together, they are drops of light on a single thread flowing into the heart of the Virgo supercluster, which itself flows into Laniakea. To imagine this is to feel both awe and silence. Awe, because the structure is so vast it outlives words. Silence, because it reminds us how little of it we will ever touch. Even if we built ships that could travel near the speed of light, we would remain bound to our filament. The distances are simply too great. We are residents of one thread in an endless tapestry. And yet, that is enough. To know that we are connected by invisible phyla, meant to galaxies we will never visit, is a kind of belonging. We are not separate from the universe, we are woven into it. The atoms in our bodies were pulled along by the same flows that shaped the web. The iron in your blood, the calcium in your bones, all were carried by these rivers of matter before they found their way into stars, planets, and life. So when you look at the night sky, remember, every star you see is part of a larger design. They are not scattered at random. They are arranged on threads that stretch across space, threads we cannot see with our eyes but can imagine with our minds. The universe is not a void filled with accidents. It is a web, a structure, a creation that connects everything. The cosmic web is the skeleton of the universe. It is the invisible architecture on which galaxies are built. Without it, there would be no spirals, no clusters, no stars, no planets, no life. The web is the hidden artist, drawing galaxies into place with the brush of gravity. As we continue outward, the story grows even greater. The web leads to the largest gatherings of galaxies, superclusters and colossal walls, structures that push the limits of our theories. But even before we reach them, we can pause here, in awe of the design itself. Because in the end, the web of creation is not just something out there, it is in us. We are threads of the same fabric. We are woven into the same tapestry. To know this is to feel less alone, even in a universe so vast. Step with me now into a wider view of the cosmic web. You have seen its delicate threads stretching across the universe, glowing with galaxies like jewels upon silk. But the story is not only about the strands, it is also about the spaces between them, the gaps, the hollows, the immense dark that lies between the lines of light. Here we find one of the most striking contrasts in the cosmos: the blazing superclusters, islands of fire surrounded by vast voids, oceans of silence. A supercluster is a gathering of many galaxy clusters bound together into one colossal structure. Think of a city so large that it holds not only neighborhoods but entire towns within it. A galaxy cluster is like a neighborhood. A supercluster is the city itself. Our local group, with its humble 50 or so galaxies, belongs to the Virgo supercluster. And Virgo itself is only one district in a far larger map, the great Laniakea supercluster, stretching over 500 million light-years and containing more than 100,000 galaxies. Superclusters are not evenly spread. They live at the crossroads of the cosmic web, at the nodes where filaments meet. These intersections are like hubs, pulling matter in from every direction. Imagine rivers flowing across a continent. Where they meet, they create lakes and deltas. In the universe, where filaments meet, they create superclusters, crowded places filled with galaxies, gas, and dark matter. The scale is almost beyond words. One of the largest known superclusters, the Hercules Corona Borealis Great Wall, spans about 10 billion light-years. To say that aloud is to invite disbelief. 10 billion light-years, almost the size of the observable universe itself. Structures like this challenge our theories of how matter can gather. According to our models, the universe should not form structures so large, and yet, here they are, immense walls of galaxies stretching far. There than thought should allow. But between these islands of fire lie the voids. These are the dark oceans of the universe, regions with almost nothing inside. They can be hundreds of millions of light-years across, yet contain fewer galaxies than you could count on your hands. One of the most famous is the Boötes Void, a region about 330 million light-years wide. In that vast gulf, astronomers have found only around 60 galaxies. Imagine floating in a place so empty that entire civilizations could live and die without ever seeing another galaxy in their sky. The contrast is powerful. In a supercluster, galaxies crowd together, pulling and twisting, colliding and merging. In a void, galaxies are scattered like lonely ships on a dark sea. Together, these opposites, crowding and emptiness, create the rhythm of the universe. The cosmic web is not uniform, it is patterned, a tapestry of light and shadow, fullness and silence. Why do voids exist? Scientists believe that after the Big Bang, matter was not spread perfectly evenly. Small differences grew over time. Gravity pulled matter into filaments and clusters, while the gaps between them emptied out. Voids are the shadows of this process, the negative space of creation. They are not truly empty, but so close to it that they feel like holes in existence itself. Speculation whispers strange possibilities. Some wonder if voids could be gateways to other regions of space-time, where expansion behaves differently. Others ask whether voids might amplify dark energy, making space there expand faster than elsewhere. If true, then voids are not just empty, they are engines of the universe's future. For now, these are theories, but they remind us that emptiness can be just as important as matter. There is also an open debate. How do galaxies that live inside voids survive? They are cut off from the rich gas streams of the filaments, so they may starve, unable to form new stars. Are they different from galaxies in clusters? Do they evolve more slowly, more quietly, hidden from the cosmic crowd? We are only beginning to study these lonely galaxies, but they may hold secrets about how environment shapes life on a galactic scale. Now return to the islands. In superclusters, galaxies are not only close, they interact constantly. Spirals collide, tearing their arms apart. Ellipticals swell as they consume smaller neighbors. Clusters crash into clusters, releasing energy that shakes the hot gas between them. The result is fire, stars igniting in bursts, black holes feeding greedily, galaxies reshaping into new forms. These are places of violence and creation, the bustling hearts of the cosmic city. If you lived in a galaxy at the center of a supercluster, your night sky would be extraordinary. Instead of the faint smudge of Andromeda, you would see dozens, even hundreds of galaxies glowing visibly. The heavens would be crowded with light, reminders every night that you were not alone. Contrast that with life inside a void, where the sky might look much as ours does, or even emptier, with only a thin sprinkle of stars beyond your own galaxy. The environment of the cosmos changes the view of its residents in ways almost beyond imagination. But here lies a deeper thought. The superclusters and voids together form the universe's largest rhythm, gathering and scattering, fullness and emptiness. Without superclusters, matter would never gather enough to create galaxies and stars. Without voids, there would be no contrast, no dark canvas upon which the light could shine. The universe needs both, the islands of fire and the oceans of silence, to be what it is. Think of a pole. Inting. The artist does not only use color, they use shadow, blank space, emptiness to give shape to the image. The cosmic web is painted the same way. Galaxies are the colors, voids are the canvas. Together, they create the masterpiece of the universe. For us, caught on one small strand of this web, the knowledge is humbling. We live in a universe that is neither evenly full nor evenly empty. It is structured, textured, alive with contrasts. And in those contrasts, we find the balance that makes life possible. The Boötes void, the Hercules Corona Borealis wall, the Virgo supercluster, the Laniakea supercluster, all of these are part of one vast design. They are names for features too large for us to truly imagine, yet they are real, mapped by our telescopes, measured in light and distance. To know them is to stretch the human mind to its limits, to press against the boundaries of understanding. And still, the pattern goes on. Beyond the largest walls we can see, there may be larger ones. Beyond the deepest voids we know, there may be emptier ones. The universe is vast enough that discovery will never end. Every map we draw reveals not completion, but invitation. So we move onward, from islands of fire to oceans of silence, from crowded clusters to barren voids, the story continues outward. Ahead lies the very edge of sight, where light itself struggles to reach us. Ahead lies the oldest light of all, the faint afterglow of creation. But before we reach it, let us pause and breathe in the vastness we already know. A universe that holds both fullness and emptiness, and balances them in beauty beyond imagination. Lift your gaze as far as it can reach. We have traveled through the spiral of the Milky Way, crossed into Andromeda, wandered through the local group, and stepped into the crowded city of the Virgo cluster. We have followed the threads of the cosmic web, passed through islands of fire and oceans of silence. Now we arrive at the farthest frontier, the edge of human vision, the deepest boundary of light. This edge is revealed most clearly through one of humanity's greatest windows to the universe, the Hubble Space Telescope. In 2004, Hubble was pointed toward a tiny, seemingly empty patch of sky in the constellation Fornax. The area was no larger than a grain of sand held at arm's length. For weeks, Hubble stared, gathering every photon of light it could. When the image was finally revealed, the emptiness had disappeared. In its place were more than 10,000 galaxies, each one a vast island of stars, glowing faintly at the edge of time. This picture became known as the Hubble Ultra Deep Field. It is one of the most humbling images ever taken. Every dot, every smear, every faint spark is not a star but a galaxy. Some are spirals like our Milky Way, others are ellipticals, others are chaotic and irregular. Some are close enough that their shapes are clear. Others are so far that their light began its journey billions of years ago when the universe was young. Think of what this means. In one tiny patch of sky, a piece no bigger than a sand grain on your fingertip, there are thousands of galaxies. Multiply that across the entire sky, and the number becomes staggering. Astronomers estimate that the observable universe contains about 2 trillion galaxies. 2 trillion islands of stars, spread across space so vast that we can never visit them all. This is the edge of sight, not because nothing lies beyond, but because light itself cannot reach us from farther away. The universe. Earth has a finite age, about 13.8 billion years. Light travels at a fixed speed, so there is a horizon around us, the maximum distance from which light has had time to arrive. That horizon defines the observable universe, a sphere with a radius of about 46.5 billion light-years. Beyond that lies more universe, perhaps infinite but forever hidden from us. The thought is dizzying. We stand at the center of our own cosmic horizon, not because we are special, but because every observer, wherever they are, has their own horizon defined by light. From Earth, we can see about 93 billion light-years across. From a distant galaxy, someone else would see a different sphere centered on them. The universe gives each of its children their own circle of vision, their own stage of wonder. The galaxies at the edge of sight are different from those nearby. They are younger, smaller, less orderly. Some look like broken fragments, clumps of stars still gathering into spirals. Others are bursting with star formation, glowing blue with the light of newborn suns. We see them not as they are now, but as they were billions of years ago. Looking outward is also looking backward. Every step deeper into space is a step deeper into time. And so, when we gaze at the Hubble ultra-deep field, we are not only seeing distant galaxies, we are witnessing history. We are seeing the universe as it was long before Earth formed, long before the sun was born, long before life emerged. We are looking across time as much as across distance. There is speculation here too. What lies beyond the edge of sight? Some imagine that the universe continues forever, stretching endlessly in every direction. Others think it may be finite but unbounded, like the surface of a sphere, curved but without edge. Still others wonder if beyond our horizon lies another universe altogether, a multiverse of infinite variations. None of these ideas can yet be proven. They remain dreams, possibilities waiting for future science. But even within the observable universe, mysteries remain. Why do galaxies gather into walls and voids larger than our theories predict? How many stars truly exist in those 2 trillion galaxies? Could civilizations live in corners so far away that we will never know of each other? These questions hover at the edge of sight, unanswered, waiting in silence. Consider the practical scale. If you tried to count the galaxies in the observable universe, one every second without pause, it would take you more than 63,000 years, and each galaxy holds billions of stars. If you tried to count the stars, one per second, you would never finish. Time itself is too short. The act of counting becomes meaningless. All we can do is imagine and let the imagination stretch us. The edge of sight is not only about what we see, it is also about what we cannot. Even with the Hubble and now with the James Webb Space Telescope, we cannot see beyond the first galaxies. Earlier than that, the universe was too young, too dense, too hot. Light could not travel freely. It scattered in a glowing fog. To go further back, we must look not at galaxies, but at the faint afterglow of creation itself, the cosmic microwave background. That lies just ahead in our journey. Still, the edge of sight remains one of humanity's greatest triumphs. To take a tiny patch of sky, to hold a telescope steady, to let the faintest photons gather, and then to see thousands of galaxies emerge, that is both science and poetry. It is proof that the universe is deeper than we can imagine, richer than we can hold, larger than we can ever claim to understand. Think of yourself standing beneath the night sky. To your eyes, it is a dark dome sprinkled with stars. But hidden in every inch of that dome are galaxies upon galaxies, layers upon layers, stretching to the edge of time. Your eyes see only the surface. The telescope reveals the depth. And so the edge of sight is not really an edge at all. It is a reminder that our knowledge has limits, that light has limits, that time itself has limits. But beyond those limits, something continues. We may never see it, but we know it is there. The unknown is not absence, it is invitation. From here, our path leads further still, not to galaxies, but to the very light of creation, the oldest signal the universe has given us. Beyond the edge of sight lies the edge of time. We have reached the edge of sight, the farthest galaxies visible across the universe, but beyond them lies something even older, something deeper, not galaxies, not stars, not planets. Instead, we find the faint whisper of creation itself, the cosmic microwave background, often called the oldest light in the universe. This light is not bright, it does not sparkle like stars or glow like galaxies. It is dim, cold, and spread evenly across the sky, a faint haze of energy that fills all of space. To human eyes, it is invisible, but to radio telescopes, it is everywhere, like the quiet hum of an old machine that never stops. To understand this light, we must travel back almost 13.8 billion years to the beginning. The universe began with the Big Bang, a moment when space, time, matter, and energy all came into being. In its first instant, the universe was unimaginably hot and dense, a storm of particles and light packed tighter than any star. For hundreds of thousands of years, the universe remained a searing fog. Light could not travel freely. It bounced from particle to particle, trapped like sound in a crowded room. But as the universe expanded, it cooled. At about 380,000 years after the Big Bang, a change occurred. Atoms formed for the first time. Electrons joined protons to make hydrogen and helium. The fog thinned, and suddenly light was free. Photons could travel without constant scattering. That first free light began to stream across the universe, and it has been traveling ever since. That ancient glow is what we now detect as the cosmic microwave background, or CMB. It is the oldest light we can see, the first message written into space. It comes from every direction, wrapping us in a sphere of faint radiation, like being inside a bubble whose surface is the edge of visibility. Looking at the CMB is like looking at the baby picture of the universe. This lig, H is stretched, cooled by billions of years of expansion. When it was released, it was as hot as the surface of a star, glowing bright. But the universe has grown since then, and the wavelengths of the light have stretched into the microwave range. Now it is just a few degrees above absolute zero, cold but still detectable. Sensitive instruments like the COBE, WMAP, and Planck satellites have mapped it with stunning precision. What do we see in these maps? At first glance, the CMB looks almost uniform, the same in every direction. But when measured carefully, tiny differences appear, slight ripples in temperature, only a fraction of a degree. These ripples are important. They are the seeds of everything we see today. In places where the radiation is slightly denser, gravity pulled matter together more strongly. Over billions of years, these regions grew into galaxies, clusters, and superclusters. The tiny ripples of the CMB became the vast cosmic web. Every star, every planet, every life form owes its existence to these faint imbalances frozen into the oldest light. The discovery of the CMB was almost an accident. In 1964, two scientists, Arno Penzias and Robert Wilson, were working with a radio antenna in New Jersey. They kept detecting a strange background noise, a faint hiss that would not go away, no matter what direction they pointed the antenna. At first, they thought it might be caused by pigeons nesting in the equipment, but after cleaning and checking, the signal remained. They had stumbled upon the afterglow of the Big Bang. Their discovery won them the Nobel Prize and gave science one of its strongest proofs of the universe's origin. Speculation follows the CMB like a shadow. Some scientists wonder if its tiny ripples might contain evidence of events even before the Big Bang, echoes of an earlier universe, or scars from collisions with other universes in a multiverse. Others ask whether the CMB could reveal new physics, hidden forces that shaped the early cosmos. For now, the evidence is delicate, open to many interpretations, but the possibility is thrilling. There are also open debates. What caused inflation, the rapid expansion of the universe in its earliest instant? How exactly did dark matter and dark energy leave their fingerprints on the CMB? Do the patterns we see in the radiation match our theories perfectly, or do they hint at something missing in our understanding? Scientists continue to study these questions, using the CMB as a cosmic map, a record written into the very fabric of space. Imagine it this way: the cosmic microwave background is like a fossil. Just as fossils preserve the shape of ancient life, the CMB preserves the shape of the ancient universe. It tells us about the density, the composition, the age, and the geometry of the cosmos. By reading it, scientists learn not only where we came from, but also where we are going. And yet, for all its scientific value, the CMB also carries poetry. It is the first light still glowing after nearly 14 billion years. Every time you tune a television to static, a tiny fraction of that noise comes from the CMB. You can hold a piece of the universe's birth in your hands, in the ordinary hiss of a screen. It is a reminder that we live not apart from the cosmos, but inside its story. The CMB also reminds us of limits. We cannot see beyond it. The light from earlier times is lost in the fog of the young universe. The CMB is a wall, the farthest back we can look with light. Beyond it lies only theory, only imagination. What happened before? Or who was there a before? These questions remain in shadow, unanswered, perhaps unanswerable. Still, standing at this wall, we feel the immensity of the journey. From the Milky Way's spiral arms to Andromeda's approach, to the Virgo cluster, to the cosmic web, to the edge of sight, and now to the oldest light. Each step has carried us farther back, deeper outward, closer to the beginning. And at the beginning we find not silence but a glow, a faint whisper, stretched thin across time but still here. Close your eyes and imagine it. A soft, uniform light surrounding you on all sides. A glow that has travelled for nearly 14 billion years to reach you. A glow that carries within it the memory of creation. That glow is the CMB. That glow is the universe's first breath. From here, our path will turn forward again, not to the past but to the future. Ahead lies the mystery of dark energy, the force pushing galaxies apart, shaping what the cosmos will one day become. We have stood at the wall of the oldest light, gazing into the faint afterglow of creation. But now, instead of looking backward, we turn forward. We ask not only where the universe came from, but where it is going. The answer is tied to one of the greatest mysteries of all, dark energy, the hidden force that is stretching the universe apart. For most of human history, people believed the universe was steady and unchanging. Stars seemed fixed, the heavens eternal. Even when astronomers learned that galaxies were drifting away from each other, it was thought the expansion might slow down with time, pulled back by gravity. After all, gravity is the great gatherer. It pulls apples to the earth, planets to the sun, stars into galaxies. Surely it would also pull the universe back together. But in the 1990s, scientists studying distant supernovae, the explosions of dying stars, made a shocking discovery. Instead of slowing, the expansion of the universe was speeding up. Galaxies were racing away faster and faster as though some invisible hand were pushing them apart. That push is what we now call dark energy. What is it? That is the great question. We know it makes up about 68% of the universe. We know it is smooth, filling space evenly. We know it acts like a repulsive force, countering gravity, but we do not know what it is. Some call it the energy of empty space itself, a property of the vacuum. Others suggest it may be a new field, something deeper than any physics we yet understand. Still others wonder if our understanding of gravity is incomplete, and what we see as dark energy is simply a sign that our laws need rewriting. Dark energy is invisible, but its effects are undeniable. It stretches the universe like an inflating balloon. Imagine placing dots on a balloon's surface and blowing air into it. As the balloon expands, the dots move farther apart. Her face has no center. Every dot sees every other dot drifting away. The universe works the same way. Every galaxy sees every other galaxy moving away, carried by the swelling of space. But unlike the balloon, the expansion is not steady, it is accelerating. The space between galaxies is not just growing, it is growing faster and faster with time. What does this mean for the future? The answer depends on the true nature of dark energy, and here the imagination opens wide. One possibility is that dark energy is constant, never changing. If so, galaxies will continue to drift apart forever. Over time, those beyond our local group will slip beyond our horizon, too far for their light ever to reach us. In trillions of years, only the Milky Way and Andromeda, merged into one, will remain visible in our sky. The rest of the universe will fade into unreachable silence. To future beings, the cosmos will seem empty and the knowledge of other galaxies may vanish. Another possibility is stranger. If dark energy grows stronger with time, it could lead to a fate called the Big Rip. In this scenario, the expansion accelerates so violently that it tears apart not only galaxies, but stars, planets, and even atoms. First, clusters would scatter, then galaxies would dissolve. Stars would be pulled from their systems, planets ripped from stars, and finally, the very fabric of matter itself would unravel. If this is true, the universe could end in about 22 billion years. A long time, yes, but still finite, still an ending written by a silent force we do not yet understand. There are gentler possibilities too. Some models suggest dark energy might weaken with time. If that happens, gravity could one day slow the expansion, perhaps even reverse it. The universe could collapse in a big crunch, returning to fire and density. Others imagine a cycle: expansion, collapse, rebirth, universes blooming, and dying in endless rhythm. For now, we do not know. Dark energy is the great unknown, the dominant force of the cosmos, yet hidden from us. It is the ocean in which the islands of matter float, and its currents decide where we will go. Scientists search for clues. They map the expansion by measuring galaxies at different distances. They study the cosmic microwave background for fingerprints of dark energy. They build telescopes to track supernovae, quasars, and gravitational waves. Each piece of evidence narrows the possibilities, but the puzzle is far from solved. Dark energy remains as mysterious now as when it was first named. Speculation is bold here. Could dark energy be connected to the quantum foam, the tiny fluctuations of space itself? Could it link to higher dimensions, invisible to us but shaping our universe? Could it be a property of time, a feature of reality itself? We do not yet know, but the questions themselves stretch our minds. The open debate is sharp. Some physicists argue that dark energy is simply the cosmological constant, a term Einstein once introduced, then abandoned, then science resurrected. Others insist that such a constant cannot explain everything we see. New theories rise and fall, but none yet answers fully. The universe holds its silence. For us, the consequences are profound. If galaxies will one day drift beyond our reach, then the universe we see now is a fleeting vision, a gift of this moment in cosmic history. We live in a special time, when galaxies still fill the sky, when the web is still visible, when the oldest light still surrounds us. In the far future, the sky will look empty, and beings alive then may never know what we once knew. Think of that. We are among the few generations able to see the universe in its fullness. We are like travelers who arrive at a festival just before it ends, able to witness the lights, the music, the gathering, before silence returns. To live now is to live in a rare window of cosmic visibility. Dark energy is a force of separation, but it also gives us meaning. It teaches us that the universe is not eternal and steady. It is changing, dynamic, alive with motion. It reminds us that nothing lasts forever. Not stars, not galaxies, not even the cosmos as we know it. And in that reminder lies a kind of beauty, for impermanence makes each moment precious. So when you look at the night sky, remember, the stars you see are not fixed. The galaxies are not eternal. They are drifting, racing, carried on a tide you cannot feel but can imagine. Dark energy pushes them and us into the unknown. Ahead, our journey will return to matter, immense walls of galaxies, colossal structures that stretch our theories to breaking. But behind them always lies this hidden force, the invisible hand shaping destiny. Dark energy, the silent wind of the cosmos, the push that decides the future of all things. The universe, stretched by dark energy, is not only expanding, it is also arranged in patterns that leave us breathless. Galaxies do not float evenly through space. They gather, they connect, they shape themselves into structures so large, so vast, that they are almost beyond belief. These are the cosmic walls, immense sheets of galaxies stretching like glowing continents across the black sea of the universe. We have already walked through the cosmic web, with its filaments and nodes, its superclusters and voids. But here, the scale grows even greater. Imagine standing at night before a mountain that spans the entire horizon. Now imagine that mountain is made not of stone, but of galaxies, billions upon billions of suns. That is what these walls are. They are the ridges of the universe, the skeleton of creation, written in fire and darkness. One of the first Great Walls ever discovered is called the Great Wall. Found in 1989, it stretches 500 million light-years across and contains thousands of galaxies. At the time, it was the largest known structure in the universe, but as telescopes improved, even larger walls were found. The Sloan Great Wall, revealed in 2003, extends about 1.37 billion light-years. Then came the Hercules Corona Borealis Great Wall, a true colossus, an estimated 10 billion light-years in length. To speak such numbers is to enter a realm where human scale collapses. Think carefully about that last one. The observable universe is about 93 billion light-years across. A single structure that stretches across 10 billion of those light-years is not a detail, it is a continent within the cosmic ocean. The existence of such a structure challenges the very theories we use to understand the cosmos. According to the cosmological principle, the universe should be uniform on the largest scales, yet here is a wall so vast that it threatens to break that rule. How do these walls form? The answer lies in the web itself. Matter flows along filaments, gathering into nodes. Over billions of years, these filaments interconnect into giant sheets. Galaxies settle into these sheets like raindrops sliding along the surface of glass. Between them are the voids, the empty bubbles that give shape to the walls. Imagine foam in a sink, bubbles of emptiness surrounded by thin ridges. The universe works the same way, but on scales we can barely imagine. The walls are not solid. They are collections of galaxies, clusters and superclusters spread across immense distances. The spaces between galaxies are still enormous, but compared to the voids, the walls are crowded. From afar they form shimmering sheets, the outlines of existence itself. Speculation blooms here. Could the walls be clues to forces beyond gravity? Do they hint at patterns left over from the first second of the Big Bang? Some scientists even wonder if their scale points to flaws in our models of expansion, or perhaps to influences from beyond the observable universe. For now, these are questions, shadows at the edge of knowledge. There is also debate. Some astronomers argue that structures like the Hercules Corona Borealis Great Wall may not be a single true wall, but a chance alignment of many smaller structures. Others insist the evidence is strong, that these walls are real, and that their existence changes how we must think about the cosmos. The argument continues, fueled by new surveys that map millions of galaxies across the sky. But whether aligned or connected, the impression is the same. The universe is not random. It has texture, rhythm, architecture. And we, tiny beings on a small planet, can read that architecture like a map, tracing the lines of creation itself. Let us try a human image. Imagine a library. Each galaxy is a book, filled with billions of stories, stars, planets, lives. A cluster is a shelf, holding many books together. A supercluster is an aisle, stretching with shelves. And a wall? A wall is the entire library, room after room, floor after floor, filled with more books than you could ever read. Now expand that thought until the library is so large it dwarfs the Earth, so large it could contain thousands of Earths, and still you are not close to the size of a cosmic wall. To live near one of these walls would be to exist in a sky ablaze with light. Galaxies would fill the horizon more than we can imagine. The contrast to a void is striking. In the wall, fire everywhere. In the void, silence. The universe is not only vast, it is varied, with environments as different as desert and forest, mountain and ocean. And yet, the walls themselves are fragile. Dark energy continues to pull space apart, thinning the bonds of gravity. In billions of years, the filaments may stretch so far that the walls lose their coherence. They are monuments, yes, but not eternal ones. They are living structures, still changing, still drifting, still vulnerable to the deep currents of time. Odd facts remind us of the scale. If you could travel at the speed of light, it would take you millions of years just to cross a fraction of the Sloan Great Wall. The largest human journeys, the migrations across continents, the voyages across oceans, are smaller than a grain of dust compared to this. Even Earth's orbit around the Sun, even the Sun's path around the Milky Way, is a tiny circle within a vast glowing sheet. But here lies something more. These walls, these sheets, these ridges of galaxies, are not just far away. They shape us too. The Milky Way itself is part of a great flow of galaxies called the Laniakea supercluster, which lies on the edge of larger walls. The gravity of these structures tugs on us, guiding the path of our galaxy through space. We are not floating free, we are part of the pattern drawn by the same currents that shape the whole. Think of it, your body, made of atoms once formed in stars, now rides within a galaxy which itself is caught in a current, which itself is part of a wall, which itself belongs to the web. You are not only a person, you are a thread in the grandest fabric ever woven. So when we say walls beyond imagination, it is not only a phrase, it is a fact. These walls stretch our imagination until it bends, until it breaks, until we glimpse something greater. They remind us that the universe is not a simple emptiness. It is a design, a structure, an unfolding. Ahead, beyond even the largest walls, lies mystery upon mystery. The nature of dark matter, the possibility of hidden universes, the question of whether infinity itself might be real. But before we step forward, let us pause in awe. Because here in the walls of galaxies we see the handwriting of the cosmos itself, and it says, you are part of something vast, something ordered, something alive with fire and silence, connection and emptiness, something BO and imagination. We have traced the walls of galaxies, the vast ridges that shape the universe. Now we must ask the question that lingers at the farthest edge of thought. Does space ever end? This is the horizon of infinity, the place where imagination struggles, where science meets silence. When we look out into the cosmos, we see a boundary. The observable universe stretches about 46.5 billion light-years in every direction, forming a sphere around us. This is not because the universe ends there, but because light from beyond has not yet had time to reach us. The universe is about 13.8 billion years old, and light can only travel so far in that time. The result is a horizon, a limit to our sight, not necessarily a limit to existence. So, what lies beyond? There are three main possibilities, each more staggering than the last. The first possibility is that the universe is finite but unbounded. Imagine the surface of a sphere, like Earth. If you walk in a straight line across Earth, you never find an edge. You simply circle back. The universe could be like that, only in 3 dimensions instead of 2. Space would be finite, but without edges, no wall, no border, only endless looping. You could travel forever and never fall off because there is no outside. The second possibility is that the universe is infinite. Space might stretch endlessly with no limit, no boundary, no looping back. If this is true, then what we see, the observable universe, is only a tiny bubble in an endless sea. Beyond our horizon, galaxies continue without end, repeating and repeating. Infinity is difficult to hold in the mind, but perhaps reality is larger than imagination can contain. The third possibility is the most radical, the multiverse. In this idea, our universe is only one bubble in a vast foam of universes. Each bubble may have different laws, different constants, even different forms of matter. Some may be barren, some may be fiery chaos, and some may hold life like ours. We cannot see them, but theories of physics suggest they may exist. If so, then infinity is not only space, but also possibility. The idea of infinity shakes us because we are creatures of limits. We are used to beginnings and endings, to walls and edges. Infinity denies all that. It stretches the mind until it bends. If space is infinite, then there are infinite galaxies, infinite stars, infinite worlds. Somewhere, perhaps, there may even be another planet like Earth, another you, another me, born of endless combinations. It is dizzying to consider, but infinity also raises puzzles. If space is infinite, why do we not see infinite light? Why is the night sky dark instead of blazing with the glow of endless stars? This question is called Olber's paradox, and its answer lies in time and expansion. The universe is not eternal. It had a beginning. Light has not had enough time to fill every corner, and expansion stretches light into invisibility, leaving us a sky that is dark but still filled with hidden fire. Science offers debates here too. Some argue that space must be infinite because we see no sign of curvature on the largest scales. Others say we cannot know, that what lies beyond our horizon is forever hidden. The truth may be out there, but we may never touch it. Speculation grows bold. Could infinity itself be an illusion? Could the universe end in ways we cannot imagine, curled into higher dimensions, folded like paper, bounded by brains in a greater reality? These are dreams of physics, mathematical whispers, but they show how deep the question goes. And yet, even without answers, infinity inspires awe. To look at the night sky is to see only the surface of something far greater. Every star is a reminder of more stars. Every galaxy is a reminder of more galaxies. Every horizon is a reminder of another horizon beyond. Infinity is not only a concept, it is a feeling, a humbling weight pressing gently on the mind. Let us pause for an image. Imagine standing on a beach at night. You see the waves near the shore, the foam, the shining water. But you know the ocean continues far beyond your sight, stretching into the dark, endless. The universe is like that ocean. We see the waves close to us, galaxies, stars, clusters. But beyond them, it continues, vast and hidden. The horizon is not the end, it is the beginning of mystery. Odd facts remind us of scale. If the universe is infinite, then the observable sphere of 93 billion light-years is like a drop in an endless sea. Every direction we look, no matter how far, would be only the start. The light we see is the faint surface of an immeasurable depth. But here is a gentle thought. We do not need to know the end to feel the wonder. Whether space loops, stretches forever, or multiplies into countless universes, the truth is already more vast than our lives can contain. Infinity humbles us, but it also frees us. It tells us that existence is not small, not narrow, not limited to what we see. It is open, wide, overflowing with possibility. Perhaps that is the gift of infinity. Not an answer, but a perspective. It reminds us that our worries, our fears, our days are small compared to that vastness. And yet within that vastness, our lives still shine as real and precious as any galaxy. Infinity does not erase us. It sets us in context, like a star against the dark sky. So let us stand here at the horizon of infinity and breathe. Let us accept that we may never know the full shape of the cosmos. Let us accept that mystery is part of beauty, because sometimes not knowing is its own kind of truth. From here, our journey turns to the unseen substance that binds galaxies together, dark matter, the invisible framework of creation. But before we move on, remember this: the horizon is not an edge, it is an invitation. The universe asks us not to finish the story, but to keep imagining. We have looked at infinity, at the question of whether space ends or continues without limit. Now we turn our eyes inward towards something far closer, yet just as mysterious, the invisible substance that holds the universe together. This is dark matter, the hidden mass of the cosmos, unseen yet essential, a shadow that shapes everything we know. When you look at the night sky, you see stars shining, galaxies glowing, light stretched across space. But this light is only a small fraction of reality. Scientists estimate that everything we see, all stars, all planets, all glowing gas, makes up less than 5% of the universe. The rest is hidden. About 27% is dark matter and about 68% is dark energy. This means most of the universe is invisible to us, sensed only through its effects. Dark matter does not shine, it does not emit light, and it does not absorb it. No telescope can see it directly, yet we know it is there because of gravity. Without it, galaxies would fly apart. Stars at the edges of galaxies move so quickly that they should escape into space, but they don't. Something unseen holds them in place, wrapping each galaxy in a vast halo of invisible mass. That something is dark matter. The discovery of dark matter was not sudden but slow, built from clues. In the 1930s, astronomer Fritz Zwicky studied the Coma cluster, a gathering of galaxies. He noticed the galaxies were moving far too fast to be held together by their visible matter. He proposed there must be hidden mass, dunkel materia, dark matter, providing the missing gravity. At the time, his idea was ignored, but decades later, new evidence confirmed his vision. In the 1970s, astronomer Vera Rubin measured how stars rotate around galaxies. She found that stars far from the center moved just as quickly as those near the middle. According to Newton's laws, this should be impossible, unless as galaxies are surrounded by massive halos of unseen matter. Rubin's careful observations gave dark matter its strongest proof. She showed that most of the universe's mass is hidden, a shadow pressing its weight into every galaxy. What is dark matter made of? That is the riddle. It cannot be atoms like those in ordinary matter because it does not interact with light. Scientists have suggested many possibilities. Some believe it could be WIMPs, weakly interacting massive particles, invisible particles that rarely collide with normal matter. Others suggest axions, tiny particles predicted by certain theories of physics. Another idea points to sterile neutrinos, cousins of the ghostly neutrinos already known. Yet, despite decades of searching, no dark matter particle has ever been directly detected. Speculation reaches further. Could dark matter be made not of particles, but of primordial black holes formed in the earliest seconds of the universe? Could it be something stranger, a form of matter existing in hidden dimensions beyond our sight? Or is it a sign that our understanding of gravity itself is incomplete, that new laws of physics wait to be discovered? The debate is fierce. Some scientists build underground detectors deep beneath mountains, shielded from cosmic rays, hoping to catch a rare collision with dark matter. Others send satellites into space to track its gravitational effects. Colliders like the Large Hadron Collider search for evidence of new particles that might explain it. Each experiment narrows the possibilities, but so far the mystery remains unsolved. And yet, though unseen, dark matter shapes the universe. Without it, galaxies would not have formed. After the Big Bang, matter was almost evenly spread, but tiny fluctuations existed. Normal matter alone would not have clumped quickly enough to form stars and galaxies. Dark matter provided the extra gravity, pulling matter into filaments, building the cosmic web. Every star we see, every planet, every living thing exists because dark matter gathered the stage on which life could appear. Imagine a skeleton hidden beneath the flesh of the cosmos. The flesh is the stars, glowing and visible. The skeleton is dark matter, invisible but essential, giving shape to everything. Without the skeleton, the body collapses. Without dark matter, the universe as we know it would not exist. Odd facts make the mystery sharper. Dark matter is estimated to be about 5 times more common than ordinary matter. This means for every particle you see, there are 5 unseen ones, drifting through space and through you. Yes, even through you. Billions of dark matter particles may be passing through your body every second, unnoticed, undetected, ghostly and silent. Speculation grows stranger still. Could dark matter form its own structures, dark galaxies, dark stars, dark planets, made entirely of invisible matter? If so, there may be entire worlds overlapping our own unseen, unreachable ghost universes drifting within ours. Science does not yet know if this is true, but the idea stirs the imagination. The open debate is not only what dark matter is, but whether it exists at all. A few scientists suggest an alternative. Maybe our laws of gravity are incomplete. The theory of modified Newtonian dynamics, MOND, proposes that gravity behaves differently at very large scales, so we do not need dark matter to explain galaxy motions, but most evidence continues to favor dark matter, though the puzzle is far from settled. For us, the lesson is humility. We live in a universe where the majority is unseen. Our eyes, our instruments, our senses grasp only a small fraction of reality. What we call the visible universe is only the tip of the iceberg. Beneath lies a vast ocean of hidden matter, silent but real, shaping everything. Think of standing in a great cathedral, lit by a few candles. You see the flicker of light on the walls, but most of the space is shadow. The structure, the weight, the pillars that hold the cathedral, these are hidden in darkness. That is our universe. We see the candles of stars, but the great framework lies unseen in the shadows of dark matter. And yet, there is beauty in this mystery. The fact that we cannot see dark matter, yet can infer its existence from the dance of galaxies, shows the power of human thought. We read the invisible by watching the visible. We see the shadow by tracing the light. This is the poetry of science, to find the hidden through the seen, to touch the unseen through reason and imagination. As we journey on, we will turn from the hidden mass to the final mystery, not the past, not the present, but the ultimate fate of the universe. Will dark energy and dark matter decide its end? Will the cosmos continue forever, or collapse, or tear itself apart? Ahead lies the last chapter, the slowing rhythm of our story, the gentle return from infinite scales to the fragile presence of our own lives. But remember this: the hidden mass is not absence, it is presence in disguise. Every breath you take, every star you see, every galaxy in the sky is shaped by a substance you cannot touch. You are part of a universe woven not only of light but of shadow, and in that shadow there is wonder. We have walked together from the spirals of the Milky Way to the farthest walls of galaxies. We have seen the first light, the push of dark energy, and the hidden mass of dark matter. Now our journey brings us to the most human of questions. What will happen to it all? What is the ultimate fate of the universe? To answer, we must think not in years or centuries, but in billions and trillions of years. The times ahead stretch farther than the mind can comfortably imagine. Yet even across such vast horizons, scientists try to follow the thread of destiny, using what we know of physics to sketch the outlines of the future. The first future is one of endless expansion. If dark energy remains steady, space will keep stretching forever. Galaxies far away will continue to drift until they pass beyond our cosmic horizon. Their light will never reach us again. Over time, only the Milky Way and its neighbors, bound together by gravity, will remain in our sky. The rest of the universe will fade into darkness. To distant descendants, the cosmos will appear empty, the truth of its vastness hidden by time. This fate is sometimes called the heat death or the big freeze. In this future, stars will slowly use up their fuel. The night sky, once alive with fire, will dim. New stars will form for a while, but eventually gas supplies will run out. The great factories of starlight will shut down. Galaxies will turn dark, filled with cooling white dwarfs, neutron stars and black holes. The universe will become quiet, a graveyard of suns. And yet the story does not end there. Black holes, the last mighty engines, will dominate. Over unimaginable spans of time, even they will evaporate, releasing faint whispers of radiation. Step by step, the universe will grow colder, emptier, until only particles remain, drifting endlessly in a frozen sea of space, a silent eternity. But this is only one possible ending. Another is the Big Rip. If dark energy grows stronger with time, its push will become unstoppable. First, galaxies will drift apart. Then stars will be torn from galaxies. Planets will be ripped from stars. Finally, atoms themselves will unravel. In this vision, the universe ends not in silence but in violent tearing, space itself shredded by its own expansion. Still another ending is the Big Crunch. If dark energy weakens, gravity may one day regain control. The expansion could slow, then stop, then reverse. Galaxies would fall back together. Stars would collide. Black holes would merge. The universe would shrink into heat and density. Some imagine that such a crunch might be followed by a new Big Bang, a rebirth of the cosmos. If so, then the universe may be eternal, not in stillness, but in rhythm, beating endlessly in cycles of creation and collapse. There are wilder possibilities. Some scientists dream of the Big Bounce, where expansion and collapse repeat like breath. Others imagine the universe could tunnel into a new state, birthing new laws of physics, new dimensions, even new universes. In some versions, what we call the end may only be a transit. The opening of a door we cannot yet see. The truth is, we do not know. The fate of everything depends on dark energy, and dark energy remains mysterious. Will it stay constant? Will it change? Will it fade? These are questions we cannot yet answer. The universe holds its future close, whispering only hints. But even in uncertainty there is beauty, because the universe has already given us so much. Stars to light the night, galaxies to stretch our minds, atoms to build our bodies, and time enough to wonder. Whether it ends in freeze, rip, crunch, or rebirth, we are part of its story. To live now is to share in its unfolding, to stand within its great age, to know that we are made of the same matter that burns in stars and drifts in galaxies. Odd facts make the fate more vivid. Did you know that in about 5 billion years our Sun will swell into a red giant, swallowing Mercury and Venus and perhaps Earth too? Did you know that in about 100 trillion years, star formation across the universe will end? Did you know that black holes themselves may take 10 by 100 years to evaporate, a number so large it cannot be spoken in normal words? These times remind us that we are brief, and yet our briefness is precious. Speculation grows softer here. Some say consciousness itself may find a way to endure, to live even in the long dark. Others imagine that intelligence, if it arises elsewhere, might discover new physics, ways to survive beyond stars, ways to carry memory across eternity. These are dreams, fragile but human, a refusal to let go of hope. And here, at the end of the journey, the debate fades. For whether the universe freezes or rips, crunches or bounces, we know one thing: nothing lasts forever. Everything changes, everything flows. To accept this is not despair, it is wisdom, because within impermanence lies wonder, within endings lies meaning. So let us return now gently from the far horizons. Let us turn from trillions of years into the present moment. You are here, alive, breathing, listening, thinking, beneath a sky of stars. Those stars burn because the universe still dances. Those galaxies shine because gravity still holds. Those atoms in your body exist because the cosmos once blazed with fire. You are not separate from the universe. You are its child, its witness, its voice. As the story slows, let us soften with it. Imagine the great walls of galaxies fading into the distance. Imagine the cosmic web dissolving into mist. Imagine the first light dimming, the last stars cooling, the universe itself becoming quiet. And then imagine your own breath, rising and falling, as steady as the tides of the cosmos. The universe is vast, mysterious, unfinished. Its fate is unknown, but tonight it is here, and you are part of it. That is enough. That is everything. Rest in that thought. Rest in the knowledge that you are stardust, held together by forces older than time, drifting through a story greater than words. Close your eyes now. Let the silence of the universe cradle you. Let the stars fade. Let the galaxies drift. Let the future dissolve into calm. The cosmos is wide, but your breath is steady. The cosmos is vast, but your heart is here. In the end, the universe holds you as it holds all things.